In this video, we'll be looking at solving simultaneous linear equations. A set of simultaneous linear equations involves two or more linear relationships. For example, we could consider y equals 2x plus 1 and x plus y equals 4 as two linear relationships that want to be solved simultaneously. Solving the simultaneous set of equations involves finding a set of values, generally x and y, that satisfies both equations. Graphically, the solutions to a set of simultaneous linear equations is the point of intersection when the two lines are graphed. So for these two, the point is 1, 3, so x is 1, y is 3, satisfies both equations. We can solve simultaneous linear equations using different methods. So we can use substitution, we can use elimination, we can solve it graphically on a CAS calculator, and we can also solve them algebraically on a CAS calculator. As a hint, you can always check your answer by substituting the values you've found back into the original equations. So if you quickly did that, if you put x equals 1 back into this equation, you have y equals 2 plus 1 equals 3, so that checks out. And similarly, if you put x and y is 1 and 3 respectively into the red equation, you'd have 1 plus 3 does indeed equal 4, so that checks out as well. So we know that that's the correct solution to that simultaneous set of equations. When solving two linear equations simultaneously, it's possible to have no solutions. So this occurs when the lines are parallel, but they are not the same line. So conditions for this is the lines must have the same gradient, but a different y-intercept. So an example of this is y equals 2x plus 3 and y equals 2x minus 1. So as you can see, the 2 is the same gradient in both, but the y-intercept is different. So over here we can see those two lines sketched, and you can see that those two lines are in fact parallel, which means they'll never intersect. So that's why there's no solutions. It's also possible to have one solution. This occurs when the lines are non-parallel. And by non-parallel, that means they have a different gradient and the y-intercept is irrelevant. They might or might not have the same y-intercept. For example, y equals 2x plus 1 and x plus y equals 4, which we've already seen, is a case where they have different gradients, so they do have one point of intersection. It's also possible to have infinite solutions. So this occurs when the lines have the same equation, and to have the same equation, they would have the same gradient and the same y-intercept. So an example of this is y equals 2x plus 1 and 2y minus 4x equals 2, because if you rearrange that second equation, you in fact get the first equation back out. So over here on the diagram, you can see that the blue and the red lines sit exactly on top of each other, and they're lightly dotted in there so that you can see that they are in fact the same equation. So there's infinite solutions along that line that satisfy the set of simultaneous equations. One method that we can use to solve simultaneous linear equations is substitution. So the method of substitution involves substituting one unknown with an equivalent expression from a second equation. So we'll have a look at this in an example right now. So we want to solve the pair of simultaneous linear equations using substitution, where we have y equals 2x plus 1 and x plus y equals 4. So the first thing we're going to do is recognize that y already has an expression in terms of x as what it is equal to. So it's possible to sub equation 1 into equation 2. So if we do that, we start with the bones of equation 2. So we've got x and then we add on whatever y is. So whatever y is going to go in this bracket. So y is 2x plus 1. And that y there comes from the equivalent expression for y up here. So we know that's what y is equal to, so we can sub that part into equation 2. And we know that all of that is going to equal 4, because that's what equation 2 is equal to. So if we simplify this, we have x plus 2x gives 3x plus 1 is equal to 4. So now this is a simple linear equation to solve, so we're going to start by subtracting 1 from both sides, and that will give 3x is equal to 3. Dividing both sides by 3 will give x is equal to 1. So that's part of the solution. We still need to now find our value for y. So to find y, we're going to substitute x equals 1, what we found over here, into either of the equations. So we're just going to pick whichever one's easiest. So equation 1 already has it in the form y equals, so we're going to sub it into equation 1, but you can check for yourself that subbing it into equation 2 would eventually get the same answer. So if we substitute x equals 1 into equation 1, we'll have y is equal to 2 times x, but x is 1, plus 1, and then y is equal to 2 plus 1 is 3. So that's the second part of the solution. So overall, we can write the solution to this set of simultaneous equations as a coordinate. So x is 1, y is 3. And hopefully you remember that that there was the solution that was already on the graph in a previous slide. Another way of solving simultaneous linear equations is using the method of elimination. The method of elimination involves eliminating one unknown by adding or subtracting a multiple of a second equation. So we'll have a look at this through an example. So we've got the same equation, y equals 2x plus 1 and x plus y equals 4, as when we did our substitution example, but this time we're going to solve it using elimination. So the first thing we need to do is we need to get these in a similar form. So this form for equation 1 is y equals a term involving x plus a constant. So we want to do the same thing over here. We want to get it as y equals a term involving x plus a constant. So to do that, we're going to subtract x from both sides of the equation. That will give us y is equal to negative x plus 4. And we're going to call that equation 3 because it's a different form to equation 2 when we're working through our problem. So to eliminate y, we've got a single y here and a single y here. So if we subtract one equation from the other, we'll eliminate the variable y. So we're going to do equation 1, subtract equation 3. And now to do our subtraction, we're going to line the equations up on top of each other like this. So we're going to have y is equal to 2x plus 1. Then we subtract away our second equation, which is y is equal to negative x plus 4. So y subtract y on the left-hand side will give 0y, or just 0. And that's going to be equal to the left-hand side where we have 2x subtract negative x, which will give 3x. And then we're going to have 1 subtract 4, which will be negative 3. Now we just have a simple linear equation to solve involving one variable. So we're going to start by adding 3 to both sides. And that will give us 3 is equal to 3x. And then if we divide both sides by 3, we'll get x by itself, and we'll find x is equal to 1. So that's the same as what we found using substitution method, so that's a good start. And now at this point, I'd like to point out that you can substitute x equals 1 into any of those equations up the top, and you would be able to find your value of y. However, for the rest of this video, we're going to look at using elimination to now eliminate x so that we can find the value of y. So to eliminate x, we've got 2x here and negative x on our second equation. So what we can do is we can go equation 1 and we can add on 2 times equation 3 so that the x's will cancel. So we're going to set up our equations on top of each other again. So we'll have y is equal to 2x plus 1. And then this time we're going to add 2 times equation 3, which will be y equals negative x plus 4. So this time we have y plus 2y will give 3y on the left hand side, and that's going to be equal to the right hand side, which is 2x plus negative 2x. So 2x plus 2 times negative x will give 0x. So overall that term is just 0, so we can forget about it. And then we'll have 1 plus 2 times 4, which is 9. So we'll have plus 9 at the end. So 3y is equal to 9. And if we divide both sides by 3, we will get y by itself. So we find y is equal to 3, which is the second part of that solution. So once again, we can write the solution to this simultaneous set of equations as a coordinate, which is going to be 1, 3. So that's the same as what we found using substitution and the same that was on the previous graph. Simultaneous linear equations can also be solved graphically using a CAS calculator. The point of intersection is the graphical representation of the solution that satisfies two simultaneous equations. So we're going to see this in the following example where we have y equals 2x plus 1 and x plus y equals 4. On the CAS calculator, go into the main screen. Next, what we want to do is type in each of the equations. So we have y is equal to 2x plus 1, and the second equation is x plus y is equal to 4. What we're going to do now is hit this button in blue, which is the graph screen. So here it may appear slightly differently on yours, but you should have a set of axes where you can graph linear equations or any equations. So if we highlight one of the equations and drag it down, that's the line of y equals 2x plus 1. And then if we drag the second equation down, that's the line of x plus y equals 4. By going analysis, g-solve, intersection, we find that the point of intersection is 1, 3. So x is 1 and y is 3 is the solution. So from the graphical point of intersection, we see that x is 1 and y is 3. So that is the solution to this set of simultaneous equations. Just a warning that when we solve graphically on a CAS, it will only give decimal solutions. Therefore, you cannot always get the exact answer. For example, if x turned out to be 8 divided by 7, or a fraction that gave a decimal answer, then it would only give the decimals, not the fraction answer. To overcome the limitations of solving graphically, the CAS calculator can also be used to solve sets of simultaneous linear equations algebraically. Once again, we're going to solve the same pair of simultaneous equations, y equals 2x plus 1 and x plus y equals 4, and we'll see how this is done on the CAS calculator. To solve algebraically on a CAS calculator, we will once again go into the main menu. And here we have our two equations already, so I don't need to type them again. If we go into the keyboard, you'll see this icon in blue. If you tap on that, you have two positions to drag equations into. So I drag one equation in there and a second equation down the bottom. So this is the way the calculator solves algebraically for simultaneous equations. And the last thing we need to do is tell it to solve for x and y. So we put the two variables we're solving for in there, separated with a comma. Pressing execute gives the solutions. So once again, we find that the solution to this set of simultaneous equations is x is 1 and y is 3. So now we've seen that elimination, substitution, graphically, and algebraically using CAS all give the same solution to these simultaneous equations. So after this video, you should be able to understand what a set of simultaneous linear equations is, understand how many solutions a set of simultaneous linear equations can have, understand the graphical interpretation of simultaneous equations, solve simultaneous equations using the method of substitution, and solve them using the method of elimination. Finally, you should be able to solve simultaneous linear equations graphically and algebraically using a CAS calculator.